pivot here and open up. So this is moment. Clear? Okay, so this is moment. So can you, without learning the theory, tell me what is moment equals to? You see a force, right? Times what?
Moment equal to the distance.
Sorry again? Moment about distance. Why distance? Let me ask you this question. You take this thing. Would you open it this way? You wouldn't. Intuitively, without learning any mechanics, intuitively means without thinking. You know that when you're born, without even thinking, you will hold at the furthest end, right? Right? Why? Because this will create the largest moment. Clear? Okay, so you remember this. Then, after drinking, you will want to wash your car. Today we're going to learn moment and another word, another term called couple. And then you have the pressure. Moment is that thing, right? Force at some distance, right? So after you drink, you want to wash your car, you go to the tap. You turn on the tap. Okay. So, of course, this story says that man commented couple and work. So next time, if anybody ask you what is couple, remember turning a tap is a couple. A couple is a subset of moment, meaning that it's a special case of moment. You turn the tap, what is actually happening? You're applying equal and opposite force, parallel forces. When there's two parallel but equal and opposite forces, this thing is called a couple. Later we'll come to that. Yeah? Yeah? Okay, good. So, that is what we're going to learn tonight. And let's take a look at the, just visualize. So, just now there was, okay, maybe let's see whether we can draw this. There was a force F, right? You would want to take a, just now you want to use a lever, right? And we are at the edge of the tin, let's say. So this is the pivot point. So what is moment? Force times perpendicular distance. This is the perpendicular distance. Later you see it's not that direct. This is called perpendicular distance. Okay? Force is always tangential to the perpendicular distance. That means 90 degrees. Yeah? 90 degrees. So this D is not just distance. Moment is not just force times distance. Not really. This D is a special D called perpendicular distance. Okay? Perpendicular distance. It must make a 90 degree with the force. Okay? So, let's take a look at your notes. This is where we stopped last week. Okay? So tonight, we're going to learn moment. Whatever notes is, whatever things are written here, I explained just now, I should give you a visual of what is a moment. Moment is a force about a point. That's called moment. That means a force at this perpendicular distance, D, will create a moment. Okay? That's the definition of moment. So, as I said in mechanics, there's not much theory. It's only the concept. The concept tonight is moment. Force times perpendicular distance. That's all. So it is how you apply this concept on real life problem, which we'll see from the example. Okay? Any question on moment? No, you can fully relate and understand what is moment. And what is the formula for moment? Force times perpendicular distance. Keep chanting that. Perpendicular distance. Force times perpendicular distance. Okay, let's take, okay, now. In forces is a vector. Moment also a vector because it's a product of a force times distance. Even though distance is a scalar, vector times scalar is still a vector. Okay? So, in short, moment is a vector. A vector is what? Defined as one that has magnitude and direction. Right? So, direction means there must be plus, minus. Okay. So, in your last lecture, force, how you define plus, minus, you define the coordinate frame, right? Coordinate system, remember? Meaning, just now I went through this part here. Remember, I mean, forces. When I define them positive, positive, all these are negative. That's how we define positive, negative for forces, right? So for moment, there are sign convention as well. How do we do it? Well, let's take a look at this example. A force, this is a force. These are different points on the cantilever or this, body. Okay? When we write M stands for moment. Subscript means the small little letter below the big capital letter. This means the pivot point. As I said, moment must have a pivot point. If a force without referencing to a point is just a force. But if it's reference to a point, it will create a moment. So, this is asking you to find the moment of this force about A here. Okay? What is the formula for moment? Force times perpendicular distance, not distance, perpendicular distance. What is the perpendicular distance? From A to this ball. You understand? Okay, now you already got the magnitude of the moment. Moment is a vector, so you require the direction. So what is the sign convention of moment? Okay. If you have an analog watch, the watch is always correct. How does the watch turn? Clockwise. So clockwise is always positive. Across, that means from now on, when we talk about moment, clockwise is positive. Anti-clockwise is negative. So how do we determine whether this force acting about A creates clockwise or anti-clockwise? This is how you do it. You take a pen or pencil up to you, hold at one end, just hold at one end. They say take moment of that force about point A, is it? Okay. Place the pen, the pivot point, hold at one end, right? Go to the reference point. Now it's A, you just put to A, okay? This pivot point means you can rotate 360 degrees, you understand? Free to rotate. So how do we determine the moment of that force about point A? You rotate perpendicular to the force. Perpendicular one. Okay? At least by doing that, you know this is a perpendicular distance. Because this makes a 90 degrees, right? Okay, so now force is a force. Start hitting the pen. How would the pen rotate if the force is hitting it clockwise? Clockwise, right? So you get a positive. Okay, now you see curlies here and there. But as I said, curlies and arrows are just for show, maybe for a start. But I would prefer you guys positive, negative. Meaning, if your answer is left as positive, it tells me that it's clockwise. If your answer has a negative, it is anti-clockwise. No need to put a curly and put a sign. That's double whammy. It makes no sense. Just take positive, negative. Okay? Just like forces. Only positive, negative. No need to show arrow. This is just to illustrate where it turns out. Okay? Okay, now, same force. Now pivot point B. Force times perpendicular distance. Minus diagonally. R2. There. How it turns? Well, take the pen, put at pivot point B, rotate until 90 degrees, start hitting the pen with the pen. Easier. How it turns? Clockwise, right? Positive. Point C. Take your pen, same logic, take your pen, hold at one end only. That pen go to the pivot point. There. Free to rotate. Rotate 90 degrees with the force. The force hit the pen. How it turns? Anti-clockwise. So it's negative. Or rather, if you put the curly, just put the curly there. Okay? Last but not least, point D. Take the pen, put at point D. The force hit at the pivot point. Does it turn? It doesn't turn. Why? Because the D is 0. How can we visualize that? Well, see, where's the pivot point for this chair? Here, right? My force applied here, I apply a force like that. Yeah? And this is the pivot point. Maybe imagine 2D, 2D from the top. Force here, pivot point here. So I take my hand. From the top, imagine from the top. Look from the top. Pivot point put here. Right? I rotate perpendicular to my force, right? I hit this chair. How will it turn? It will turn what? This direction or from the top is anti-clockwise, right? Okay? Correct? Yeah. So how Why did I say that if your force is at the pivot point is here. If my force is here, would my pencil turn? It will not. See, if my force is here, does it turn? So can you understand? Why it doesn't turn? Because V is 0. Can you imagine? Force goes straight to the center of the pivot point. The V is 0. Okay? So if you fully understand what I'm saying, you won't have problem with moment. Okay, now take a look at this. So these are the essential things about moment. The concept is just like that. The formula is just one formula. That's all.